Assalamu alaikum and salam jahtara. This is the last chapter of the course, chapter 6, which is areas and volumes. So as introduction, what we're looking at, we'll be looking at techniques or methods commonly used to calculate areas and volumes of soil or material in design and in the construction of typical civil engineering projects. So why do we need this? Why do we know? Why do we need to know? Why do we have to have this knowledge? Because simply land acquisition and earthwork are normally expensive. So to function effectively as a civil engineer, you should have the necessary knowledge to estimate or to calculate areas and volume so that the project cost or the initial estimate of the project is within budget. So if you would have do this badly or would have done this badly, then your budget or your estimate could just, blow up through the roof. So what we're looking at in this chapter, what is the content? We'll be looking at, firstly, areas from plans. And we're talking about plans. We'll be either looking at what we call as a regular boundary, which simply means areas of a figure with straight boundary lines. Okay, we call it regular boundary. Or conversely, we'll be looking at areas with irregular boundary, meaning boundaries which are not straight lines, could be a curve or could be wavy, and so forth. Then we will be also looking at area from cross sections. We'll be looking at the ways, methods in calculating or estimating cross section, because we need the cross sections to do subsequent processes in volume calculation. And lastly, volume, we'll be looking at a few methods in there. We'll be looking at mathematical methods. We'll be looking at graphical methods and some simple straightforward methods. Okay, so basically we're looking at area from plan, area from cross section, and to use those figure, those info that we obtain from areas to come up with volume calculation. Okay, let's kick off with the first one, regular boundary. Okay, when we say area or figure to calculate areas of a regular boundary, it could simply mean something like this. Okay, we have, in this case, a parcel of land. Okay, similar to your traverse line, I would say. Okay, you have your distances as well as your bearings or your angle, then you can simply obtain the area. So a typical example would be something like this. Division, lot division of a plot of land into parcels, and those are considered as regular boundary areas. Formulas would be quite straightforward, and these are the things that you have came across during your pre-university days or high school. Okay, you could either use a simple right angle triangle formula, half base times height, like that, or you use the sides, the length of all the sides, the fraction of that, or you can use angle, okay, to calculate the area. So when we're dealing with more than 3 sides, I think the best method to use, and if you learn it in your traverse, is just to simply apply the cross coordinate method, the cross multiplication method. Okay, so no matter how many points we have. As long as we know what the coordinates are, we can simply apply the cross multiplication to obtain the area of the figure. So that's area of regular boundary, and I think it's quite straightforward. Next, we're moving into a regular boundary. So I've got on the screen now an example where the area is marked with a red line, and you can clearly see that it's not actually the straight lines. They're basically curvilinear or curved lines, and in this case, it's a line to demarcate or to mark an area. I think this is a hydrology study. So this is to demarcate what we call the watershed. Okay. Sometimes it's called or sometimes referred to as water basin. Okay, water basins. Excuse me, I've got to go back there somewhere. Previous. Okay. Sometimes called basin or water basin. So this basically represents an area where it rains. Okay, if you could see, the river starts from there, and you got streams there going down that way. So all this will be collected, okay, from that creek or from that river, as well from that river there. So you will learn this, okay, when you do your hydrology later in your studies. But anyway, so this is to demarcate the high area, so the limit of the water basin. And in this case, you might have to find out what is the area, okay, of that watershed area. Okay, area for figures with irregular boundaries. There are three ways of dealing with them. We can find the areas. There are three methods that we can apply. We can apply the graphical method, simply uses grids and counting squares, and I believe that you've done this sometime before, okay? And we could simply have the area that we are interested in, like the one that I showed earlier, and we just simply lay a grid on it. So if we know what our scale is, we can figure out what's the size of one grid like that, and we'll be counting all the grids, the complete grids, and at the edges we'll be estimating, okay, quarter grids or half a grids area to come up with the area, the total area of the basin. Okay, so that's very straightforward, simple. And the smaller the grid, or obviously the smaller the grid, the better approximation you'll be making as compared to having a larger grid. So that's the grid method or graphical method. Then we have what I term as mathematics. Okay? We use formula, trapezoidal formula, and Simpson formula. So what is it all about? Okay, let's look at this example again. We can simplify the problem by perhaps drawing a figure like that. If we draw a figure like that, so it's a regular figure, we can determine what the area is. Okay. So if I could fit as many as I can in there, like so, so that will actually solve some of my problem, okay, of getting the area, okay, by calculating the areas, the regular areas. So what I will be left with will just be the areas at the edges. Yeah, the area there. So that's what we'll be discussing. That's what we'll be looking at now, how to come up with the area of the edges. All right. So, excuse me, I just proceed from there. Let's look at the trapezoidal rule. Okay. So this is show on the screen. It shows one of the edges, which is a curve. Okay, whereas the blue line represent the area that we have marked, a regular area that we have marked earlier, and it's a curved line. Okay, but to come up with the area, so in trapezoidal rule, what we do is we will assuming that those line or the boundary is a series of straight lines. Okay, a series of straight lines like shown in there. Okay, with regular, what I say, strips. Yeah, I'm going to call them strips. So the strips could be of certain length, and in this case, O simply means, or I term it as ordinate. Okay, O is the ordinate, ordinate 1 to ordinate 9, so that simply gives the distance from the regular line, the regular boundary line, to the irregular boundary. So if they are given as O1 to O9, in this case I divided the area into 8 strips or 9 ordinates, and the distance between those strips is L throughout, and I can simply calculate the area of the first strip by looking at, or by applying the trapezoidal rule. Okay, taking the first ordinate, second ordinate, mean them and multiply by L, and I can repeat that for the second strip, the third strip, and so on till I get to the last strip. So the total area would be area 1, which is that one there, area 1, okay, area 2, area 3, and all the way to area 8. Okay, so general in general form, we could write, okay, the area is given by the half of the interval. Okay, then that will be multiplied by the sum of the first and the last, whereas the rest of the ordinate will be the sum and we multiply by 2. Okay, because you're going to use those ordinate twice. Okay, so that will be the trapezoidal rule. Okay, now we're moving on to Simpson Rule, and if you can recollect what you've learned in pre-university or high school, you came across a Simpson Rule for approximating area under a curve by simply doing an integration. So we're going to apply that knowledge, or that principle or that approach into our purpose. Okay, so if that is a figure again, okay, now we're not going to assume or make approximation that the boundary line is straight. Okay, but we're going to fix it as it is. We're going to use Simpson, whereby we want to take the curvature of the boundary, and if the ordinates are still the same and the distance or the strips, the interval between the ordinates are still L, so Simpson says, using that formula, says that the area, which is both of these strips, okay, is equal to a third of L multiplied by the sum of the first 01 and 03 and 4 times 02. So that's that Simpson rule. Okay, and similarly for the next area, we'll be looking at this one, okay, the next two strips. So the concept is you will be using two strips at one time, okay. So the same goes to the third area, which is going to take strips, those two strips there, and the last area, those strips there. So if we add them up, total area will be A1 to A4, and that will be the summation, okay. And in general, we could say the area will be a third of the interval or the length plus the first ordinate, okay, and the last ordinate. Got to sum them, and you got to sum all the even ordinates, multiply by 4, and sum all the odd ordinates and multiply by 2. Okay, so that will give you or furnish you with the area that we are interested in. Okay, so having gotten that area, then we add up to the regular area that we have calculated previously, so that the total will give you the area of the watershed area, or the water basin that we are after. Okay. Now, so we've got Simpson, we've got Trapezoidal Rule. So when it comes to choosing, Simpson is a better approximation because it takes into account the boundaries is curved rather than straight line. So we should give preference to Simpson, but in order for Simpson to work at one go, you should have an odd number of offset. So in cases where you have even number, okay, you could either use trapezoidal all the way, but to make things to make the approximation a bit better, I would recommend to use Simpsons up to the last odd offset, and the last strip will be using trapezoidal. Okay, so it's a combination between Simpson and trapezoidal. So in a nutshell, what I'm trying to say is Simpson should be given the first choice. Okay, when it comes to calculating area with irregular boundary. Okay, the next one that we have, if I can just go back, let me stay there. If I can just go back, so that's mathematics. Okay, so the next one we have is mechanical. Okay. Now, I think be aware that, I mean, the one that all these three methods that we have discussed are methods that you might need, or methods that you use when you have to do when you have a hard copy, okay, a hard copy map. Okay, if you have a digital map, you have used any suitable CAD software to come up with the area. So what I'm trying to highlight now is you consider yourself having a map, a physical map, and you've got an area on the map that you need to determine, and this is not too elaborate, simple, straightforward, and probably scanning the map would not be an option. So these are the methods that you apply. Okay, so let's look at the last method there, mechanical. Why do we call mechanical? Because we use instrument. An instrument is called a planimeter. Okay, when we want to determine the area. So planimeter looks something like this: an instrument with an arm, okay, and a tracer, some keys there, numpad, should I say number pads, a keyboard, a small keyboard for us to put in to input data. Okay, there are many versions or many examples of planimeter. We've got digital ones, we've got analog, that's truly analog. Okay, we've got an arm version, we've got a roller version, a version with printout. Okay, those are planimeter. Okay, it's quite useful equipment. Okay. As I say, it'll be very useful if you are dealing with a hard copy, a plan, a physical plan. Okay, this is a video just to show you how it works. So what we have here is a map, 200,000, the scale is 1 in 200,000. It's a map of Norway, and what we're trying to do here is to find the area of this lake. Lake Esrum or Esrum, I'm not sure how to pronounce it, but anyway, it's in Norway. So we're going to use that planimeter. So we have input or inserted the scale there, it's 200,000, and we can start do the measurement. Okay, so you're going to take a point on the map. Okay, I'm going to press start. Then you start from that point, and when we do, you can see the tracer there, like a marker in the middle of the magnifying glass. So for it to work, for it to get the correct answer, you have to follow the figure clockwise. Okay, you got to go clockwise and came back to where you or come back to where you started from. Okay, and if you look in the process of doing that, that number there, okay, keeps changing, and that's to show you the area. So in this case, it was found that the area is 17.2 kilometers square in this case, and I think you realize that the number that we obtain here, how good that number is depends on how well we follow the shape of the figure that we are measuring. So in normal cases, we have to probably do it 2 or 3 times and get the mean. So I've checked on the internet, and excuse me. Okay, so that's the area that we obtained. So I've checked on the internet. The internet says the area is 17 kilometers. The Lake Esrum is 17 kilometers. So more or less good. Okay, it agrees. So I'm sure if I do it a few more times, I get the best answer I could possibly obtain. So that is planimeter. Okay.
انضم معنا الآن واشترك بالقناة ليصلك كل جديد. YSAG، معا نحو مستقبل مشرق.